Hello friends, in today's Core Basics coding tutorial we are going to talk about multithreading in Python. Before we begin with Python multithreading, let's first understand in general what multithreading means when it comes to computer science. Multithreading I often explain by giving the example of a busy mom. As you see in this picture, busy mom usually juggles between multiple tasks. So she might be cooking food and at the same time she has to take care of baby, and she often gets a phone call and she needs to handle that as well in parallel. So as you see on the right hand side, mom starts by cooking food, and at some point you see in the green line, she has to switch to another task of taking care of a baby. And then at some point here she gets a phone call, so she needs to handle that as well. So in this time period, so this vertical slice indicates the time progression. In this time period she's cooking food, taking care of baby, and handling phone call. So each of these lines are individual tasks that mom is handling, and when it comes to programming they are called threads. So mom is handling 3 threads: cooking food, taking care of baby, and handling phone call. Hence mom is doing multi-threading. Similarly, Python program can handle multiple tasks at the same time, and that program is called to be doing multi-threading. Okay, so we are going to work on a problem where I have an array, a list of numbers, and I want to calculate the square of each of these numbers, and I want to print those numbers. At the same time, I want to calculate cube of each of these numbers and print them. So I have to handle 2 tasks basically: calculating squares and calculating numbers, calculating cubes of these numbers in the array. So it's simple to write 2 functions. So what I have written here is, I have written the first function, which is calculating square, which takes numbers array as an input. I go through the array and I print the square here. Now I'm introducing a time sleep. So this time module, what it does is it waits for 0.2 seconds before printing this number, and I will tell you in a bit why I'm doing this. But for now, just assume that this goes through an input array and it just prints square of each of these numbers. This function is exactly similar to this function, except that instead of square it is calculating the cube of those numbers. Okay, and I'm calling calculating square and calculate cube one by one, and then I'm printing done when I'm done. And I'm also doing something else, which is calculating how much time it took to execute these 2 functions. Okay, so it's fairly simple program. So let me just run it. Okay, so as you can see here, I have this array 2, 3, 8, 9. It first printed 4, 9, 64, 81, the square of these numbers and the cube of these numbers. So cube of 2 is 2 into 2 into 2 is 8. 3 cube is 27, because 3 into 3, 9 into 3 is equal to 27, and so on. Overall, this program took 1.6 seconds. Let me execute one more time. Again, it took 1.6 seconds. So note down this number. This program is taking 1.6 seconds to execute. Okay. Now, the reason I introduced this time delay here is that just to demonstrate in which scenario multi-threading could be useful. Here you're first calculating square and then calculating cube. Now when you're waiting here, what's happening is your CPU is idle. See, your CPU is doing nothing. Okay, now you might have this scenario when, let's say in real life, you might be calling a web service, or you might be waiting for a packet on your network socket. So at that time you're waiting and your CPU in your PC is not doing anything. Multithreading tries to utilize this idle time and during that idle time you want to give CPU some work. Okay, so let's use multi-threading and improve this number. So it's taking right now 1.6 seconds. Using multi-threading we will improve the time, we'll execute this program much faster. Okay, so first thing you need to do in order to use multi-threading is import threading module. Okay, this is a standard Python module used for multi-threading. And now instead of calling these functions directly, so I'm going to remove these, and what I'm going to do is I'm going to create a thread. So I'll say threading dot thread. Okay, and target equal to, so your target is your worker function, the task, simple task that you want to execute. This is similar to mom taking a phone call, for example, or handling baby. So in our case that task is calculating square. Okay, so you mention your function name after target, and in your args you will mention your arguments. So here your arguments is your array. So this is a tuple that you're passing as an input. So if you have multiple arguments to this function, you will pass multiple arguments here. Okay, so this way you created the first thread, and now I'm going to create the second thread, and here my function will be calculating cube. Okay, so by doing this I'm creating these two threads, T1 and T2. Now I just created two threads, and I need to start them now. So I will say T1 dot start, then T2 dot start. So this will execute these two programs in parallel. Okay, and then you need to say T1 dot join, T2 dot join. What join will do is it will wait until this thread is done. Basically T1 dot join means now wait here until T1 is done. T1 meaning until this calculate square function is finished, and then you want to print done. Okay, so let's execute this program now. Nice. So as you see here, now what it is doing is it is not executing these two functions in a sequence. So first it calculated a square. Okay, so it calculated a square here, then it went into this loop one more time, and then it started waiting. So while it was waiting here, the other function was also executing in parallel. So meanwhile it printed cube. So you see cube here, so that's why you see square and cube, because there are two tasks being performed simultaneously in parallel. Okay, so whichever task gets done, you get the output of that here, and you see that now our program is taking half the time compared to what it used to take before. So here is 0.8. If you recall, previously it used to take 1.6 seconds. Now it is taking only 0.8 seconds. Okay, now let's compare this with our BusyMom example. So here the main program started, so this red line is called the main thread. Then at some point we started calculating square of numbers, so which is this green line. So we just spawned a new thread, which is this green color line. So that we did by doing this T1 dot start. So when you say T1 dot start, what you're doing is you are just basically starting execution of this new thread. Then at some point you started calculating cube of numbers, which is this T2 dot start, and then when they are done, they come back to this main program. So these points here are basically T1 dot join and T2 dot join. Join means you are done with your individual thread. Now the execution joins back into your main program, your main thread. Okay, so again, comparing it with BusyMom is kind of very similar thing that your program doing. Okay, so multithreading is typically used when, as I explained previously, when your CPU is idle, it is waiting for something. I didn't have a sophisticated example, that's why I introduced artificial delay. But in your real life, you'll be calling, let's say, web service. Web service might take few seconds to give you back the response. During that time, if you want to optimize the performance of your program and make your CPU do some work, then you can definitely use multi-threading. Now, multi-threading in Python is a little special because there is something called a global interpreter lock that prevents you from using the true benefits of multi-threading. But in any case, whenever you are waiting and when you are doing IO bound operation, you can still use multi-threading. So go ahead and use it. And if you want to do real CPU intensive work and you're not waiting for an IO type operation, then you need to use multiprocessing. So all those are little advanced concepts which we will cover in future videos. Okay, so that was a sweet little introduction on multithreading. Thank you very much for watching.